Oh boy. Hey everybody. This is derivatives day 2. This is derivatives day 2. And again, I think derivatives day 2. And I think just to keep things simple again, I'm just going to go through a couple examples, and then tomorrow, instead of new notes, it'll just be several problems. And then the day after that, it'll just be several problems. And then we will be, say it together, we will be done. Not, forever, but just for a little while. Okay, so let's do derivatives day 2. Hey, this one, this meme made me chuckle. It's just funny because how many kids are going to get burned when it comes grade time? Yeah, Mom, I already got my homework done. Gosh. All right, here we go. Here's what we know so far. Okay, so just a refresher course. If I said, hey, what's the derivative of something like 5x squared? Well, that answer would just be 10x to the first, or just 10x. Okay, if I said, hey, what's the derivative of, I don't know, x? Oh, we didn't talk about that. The derivative of x, just a variable, would just be 1 times x to the 0, because there's a 1 here, yeah. So then that would just be 1. So the derivative of z is 1. The derivative of a is 1. Okay, so didn't talk about that. If I said, hey, what's the derivative of, oh, is that all that we did? Maybe that's all we did. How lame would that be if that's all we did? Oh, let's put a plus sign in there. Let's say it was 6x cubed plus 2x squared. That would just be 18x squared plus 4x. Okay, so just remember, you're just taking this times that and then subtracting 1, and then taking this times that and then subtracting 1. And that's it. That's the derivative, okay? So, what if things look a little more complicated like this? Hey, what's the derivative of something like 3x squared minus 1 and 5x plus 6? Okay, now there's a couple ways to do this problem. The first way is to just FOIL it out first. Okay, so I basically be saying, hey, what's the derivative of, let's see, 15x cubed plus 18x squared minus 5x minus 6. Okay, and then you would just say, so all I did was just FOIL there, right? And then you'd say, well, the derivative of that puppy would then have to be 45x squared plus 36x minus 5, and the derivative of a constant is 0. The derivative of a constant is 0. Okay, but there's something called a products rule, and so I need to show this to you because it's going to come into play. So that was the easy way to do the problem. Let's do the problem one more time. Let me go to split screen. Let's try that again. Let me go to split screen. Let's try that again. Why isn't, how come I can't, it's not even, how come I can't even, oh, boo. All right, so here's something that you probably need to learn also. So let's do the problem again. 3x squared minus 1 and 5x plus 6. It's not letting me do split screen. What a crock. All right, so here's what it says to do. There's a new, it's just called a products rule. Okay, and basically it says this. Write down the second term and multiply it by the derivative of the first. That's right, derivative. Then put a plus sign. Then write down the first and multiply it by the derivative of the second. Well, the derivative of 5x plus 6 is just 5. Then that would be 30x squared plus 36x plus 15x squared minus 5. Hey, let's see if this works. So that's 45x squared plus 36x minus 5. Let's go back. 45, 36, 5. 45, 36, 5. 45, 36, 5. 45, 36, 5. Okay, so either way works. The products rule you'll run into when things get a little more complicated as far as like when you start doing trig terms. By the way, just for the heck of it, just a little side note. There are derivatives of trig terms also. So I said, hey, what's the derivative of sine x? Well, the derivative of sine x is cosine x. And if I said, hey, what's the derivative of cosine x? Well, you would think it would just be sine x, but it's not. It's negative sine x. There's proofs behind all of these. And then how about let's just do tangent. Hey, what's the derivative of tangent x? Anybody want to take a guess? What? What? I can't hear you. It's secant squared x. Very good. Okay, so those, you know how when we did trig identities and you had to memorize some stuff? You know, like tangent squared plus 1 is secant squared. Well, when you start doing derivatives like cool stuff, you're going to have to memorize cool stuff like the red stuff. Okay? And so I've almost talked too much. I just wanted to make this a 10-minute video. Let me show you the quotient rule, and then we will be done. Okay, so the quotient rule, so there's no work again today. Quotient rule for derivatives looks like this. It's low d high minus high d low all over low squared. So I've never taught calculus here at the high school, but some of these things have just stuck with me, yeah? So let me show you this. So let's say I'm going to use the same things as before, but this time I'm going to make it a fraction. Let's make it 3x squared minus 1 over 5x plus 6. Okay, so now it's division. That's what quotient, you know, you have to be dividing. So if I said, hey, what's the derivative of that? Like that, here's what you do. It's low, so it's 5x plus 6 times the derivative of the high. So the derivative of the high is 6x minus high, which is 3x squared minus 1, times the derivative of the low, but the derivative of 5x plus 6 is just 5, all over the bottom squared. And just to save time, I'm just going to leave that. I'm not going to FOIL it, but obviously we could. All right, so then this would be what? 30x squared plus 36x minus 15x squared plus 5 all over that mess squared. 5x plus 6 squared. And then that would be what? 15x squared plus 36x plus 5. 15x squared plus 36x plus 5 all, oops, I said 5, but it didn't write it. All over 5x plus 6 squared. And I could FOIL that, but I'm not going to. Okay, so tomorrow I'll refresh your memory again one more time about derivatives, and then I'm going to give you, I don't know, 3 problems, maybe? And then don't turn them in tomorrow. And then I'll give you a couple more problems on Friday, maybe a few, so maybe 3. And then you'll turn it in on Friday and be done. Okay, I say to you, good day!